Hello everybody. In this video I will discuss the main concepts of chapter 1, basic ideas, and I will talk about some common mistakes that I've seen over the years and some tricks to remember for the test. Let's go ahead and start with population and sample. This concept is actually at the center of study of statistics. Okay, so let's see what's going on here. Let's say we have a population of interest, and it could be all sorts of things. But let's say our population is FCC students, and we would like to know something about it, about these people. One of the things that we can ask them is the average commute time, right? So let's say I wanted to know the average commute time of my students. Okay, commute time. Well, it is very unreasonable of me to ask every student how long it takes them to get to school, so I can't do that. But what I can do, I can find a sample of students, okay, and find their average commute time. So let's say I've taken a sample of 50 students, and I found their time, the mean time, x bar. What I'm going to do, I'm going to say, okay, that number, whatever this is pretty good estimate of my population average commute time. Okay, that's what we're going for here. That's the main idea of statistics. You want to know something about population. Okay, in order to do this, we need to find a good representative unbiased sample that we can compute the statistics. Okay, so this guy right here, x bar, that's your statistic. This guy right here, mu, that's your population parameter, right? And we're going to say, okay, because the sample was unbiased and most likely simple random sample, this is a pretty good estimate of our population parameter. Okay, that's pretty much the big picture of statistics. And the first 6 chapters, what we're going to do, we're going to learn the tools how to do it. Okay, and then chapter 7 and 4 and further, that's all inferential statistics, basically making these conclusions, okay, about population. So that's the difference between population and the sample. Sample comes from population. It tells you something about the population itself, but the idea is it needs to be really good. Okay, the sample needs to be a good one. Okay, so let's keep going. Let's take a look at the next concept. So sampling methods. You should know a whole bunch of them, right? So simple random sample, that's the best way in many situations. That's when you have a population and let's say you want to pick 20 subjects out of this population, then every collection of 20 subjects will have an equal chance of being selected. Okay, then we have stratified method, cluster, we have systematic, and convenience. Okay, so these are the 5 main methods. Of course, there are many more other types of sampling methods, but these 5 are the ones that you guys should know. And here students are rarely having any issues. The main problem that I see is students confusing these two. So what's the main difference here? When you have a stratified method, you split your population in stratas, right? So let's say you have population and we split them in stratas. And then you take a sample out of each one of these stratas, okay? So let's say I have 6 here, and I take a sample out of each one, and that's my sample, okay? That's stratified. And then cluster, well, let's take the same population, we have, let's say, 6 clusters, right? Then cluster would be, okay, I'm going to take this one and this one and select all of the subjects in each of these clusters, or maybe a relatively large sample, okay? But you don't do all of the clusters. So that's the main difference. So what may be helpful is to make a picture like this, depending on the scenario, and see which method is being used. Okay, everything else usually is pretty straightforward. So these are your main sampling techniques, and then the next thing is types of data that we need to know. Okay, again, this concept seems really easy, but this is one of the crucial concepts in particular. Once we get to inferential statistics, this will be your first step, trying to figure out what type of data is given to you. So there are two types of data. You can have quantitative, right? Quantitative data, or categorical. All right. Quantitative data. What would be an example of this? Let's say weight. Okay. Quantitative. How do I know? Weight is measured. So let's say in our case it's measured in kilograms. Okay. As soon as you see units of measure, you know this data is quantitative. Okay. What would be another example? Let me think. How about number of children? Number of children in a family. Okay. So the units in this case would be the kids themselves, right? So you can count them, 1, 2, 3, and so forth. So that's your number of children. All right. Then categorical. Here, no measure, you cannot measure it. So what could be example? Any characteristic that is just kind of like a label. So female students, proportion of female students at FCC. Then what else? Part-time students, right? So part-time students. Okay, so think about it this way. Let's see. Quantitative. Your main interest here will be about a mean that we don't know. Mean. Categorical. This is about proportion, right? So this one will be measured in percentages. This one is measured in whatever the units are, right? So quantitative, categorical. This is very important. Typically students have very little issues trying to figure out which one is which. Okay, so as long as you can measure it, it's some sort of units, that means it's quantitative, right? If it's proportion, if it's some labeling like female or preference in color, then of course it's categorical. Okay. Now, once we get to quantitative, there's a couple of things that can happen here. It's either continuous, or discrete, and that's where some mistakes can happen. So, what's an easy way to remember? Discrete. Discrete means that I can count it and there's no decimal points. Okay, so for example, number of children, we go 1, 2, 3, and so forth. Okay, so you cannot have 2.5 kids, right? Or 2.75. These numbers cannot take any decimal value in between. So the number of children is discrete. Okay. Another example would be points in, let's say, basketball game or football game. Okay, they will not take decimal places. What about continuous? Continuous. This is going to be the case where your variable can take any value between, let's say, 0 and 5, or 0, any other number that you can pick. So, let's say in kilograms, right? So when babies are born, let's say they're born at 3,500 grams, which is about 7 pounds. As they grow, their weight is actually taking every single value between 3,500 grams and up to whatever their weight is. Okay, your kid will not grow overnight. The weight will not jump from 3,500 to, let's say, 4 kilograms. Right? It will actually take every value. So if a variable can take any decimal, then it's continuous. All natural processes like weight, height, temperature, snowfall, all of those are continuous. Okay? So over here for categorical, we do have nominal and ordinal, right? But don't worry about that, okay? I will not ask you to classify the variables in like this, okay? But I do want you to know which one is discrete, which one is continuous, okay? So that's your types of data. And then the last concept in this section is experiment versus observation study. So you just need to know which one is which. Students have very little trouble with that. In experiment, we have treatments that are given, right? Treatment. What would be a good example of an experiment? And I want to make sure that we focus on this. It's not chemistry or physics experiment that you guys do in your lab, right, when you go to class. This is a statistical experiment. So clinical trials would be a good example. Clinical trial. Okay? For example, there's a new drug. So let's say there's a new medicine that, let's see, reduces your headache. Okay? So let's say you have a new medicine that helps headache. So why do we want to get the new medicine if we already have that something works, but maybe this one is less expensive, maybe this one has a fewer side effects and so forth? So what's going to happen, you will have 3 groups most likely. One will have this new medicine, another one will have placebo, and this other group probably will have nothing. And these 3 groups will produce different results, right? So different treatments usually produce different results, or maybe they won't. Maybe they'll produce the same result, okay? So the statisticians will collect data and say, okay, come up with a conclusion. Okay, this drug is good. It helps to reduce headache. It has fewer side effects, and so forth. Or they'll say, well, statistically saying, this makes no difference which one you take, right? So, but the main idea here is that you have treatments that you give to your groups, and you have control over which group gets what treatment, okay? Unless it's a blind experiment. And then in observation study, there are no treatments. There's no control. So here, you just observe groups of people or some other subject and see how something is affecting their characteristics. So for example, what would be one observation study? Let's say you observe mothers to be and we can look at the mothers that smoke and the ones that don't smoke. Okay, cigarettes. So we can see how smoking tobacco affects, I don't know, many factors of the children, right? So here, of course, this would be an observation study. There's no control over who does what, and then you collect the data over the years, make conclusions. Okay, so I know there's other concepts in chapter 1 that you went over, such as biases and maybe a couple more things, but these are the main things that you guys should focus on. Okay, 5 more chapters and we will be ready for midterm. Hello everybody. In this video I will briefly go through the main concepts of chapter 2. There are 4 sections in this chapter, but we will only focus on the first 2. The third section wasn't even assigned, and the last section talks about how different graphs can be misleading. Don't worry about these 2, okay? So I won't be testing you on any of that material. What I would like for you just to know is the first 2 sections. So the first one talks about graphical representation of categorical data. And so there are 3 things that you need to know from this chapter is frequency bar graph, relative frequency bar graph, and pie charts. So this is your activity 2, and most of you guys did really well. In general, on this particular chapter, there's usually very few problems. So let's talk about frequency bar graph and relative frequency bar graph. Actually, these 2 are very similar. Okay, these two, how they're different. They will have the same shape, right? Same shape. Okay, if you have a frequency bar graph, you just have counts of your categories as bars, right? And the higher the count is, the taller the bar is for that particular category. With relative frequency, you just have proportions or percentages, right? So proportions or percentages here for relative frequency bar. But the picture itself will be the same. So if you go back to activity 2, and here we were interested in different types of vehicles, right? So we have 4 types. If I just give you these numbers, of course you can read them and say, okay, sure, there's 15 motorcycles, 85 sedan, and so forth. But if I give you this picture right here, it gives you a nicer idea of what's going on. So there are more sedans than any other vehicle, and that's not surprising, right? But it kind of gives you a pictorial representation of a real life situation. Okay, so this one is in particular is a relative frequency bar. Okay, and notice how we have gaps in between the bars. Also, if you were to put this in different order, so let's say you wanted to put SUV first, then truck, then motorcycle, it wouldn't change the picture, right? So, well, the shape would be the same, but really the information would be still presenting the same type of data. So the order doesn't matter here, and we have gaps between the bars. Okay, so let's see, frequency bar, relative frequency bar, and then pie charts is really the same thing. It's as the frequency bar, but only it has a different way of presenting it, right? So if we go back to this activity, you can see here that gives you just another way of looking at it, right? So different type of people prefer different types of representation. So this gives you an idea. Oh, okay, so almost half of these vehicles were sedans, right? And very few were motorcycles. Okay, but these two pictures tell you exactly the same information. So on your midterm, I will not ask you to construct any of these type of pictures. Okay, I would provide a picture to you guys and say, all right, read this information, answer these questions by looking at the picture and answering the questions. And again, typically this is not a problematic concept. The mistakes that happen usually just not paying attention. Okay, and that's it. So that's for the graphical summaries of categorical data. Now, what if we have quantitative data? What do we have there? So quantitative data, okay, what are we dealing here with? So the main characteristic of this type of data is the mean, right? So for the first concept, we were talking about proportion. Here we'll talk about mean. The data can be measured in some units, right? Okay, so what do we have here now? Now notice we still have frequency histogram, now relative frequency histogram, not bar graphs. These are two different types of graphs, right? And then we'll talk about shapes of histogram. So what is the deal with a histogram now? For a histogram, the order matters, right? So order matters. Okay? If we were to, let's say, make a histogram of test scores, and let's say we'll go by 10, right? So let's say we got this type of picture here, 90 to 100. Okay, and let's say I've collected some data for my statistics students. I don't know, let's say 10 classes, right? And this is what I got. Let me see. So something like this. Okay, so this would, let's say, represent some percentages, right? So what does this tell me? Okay, well, it looks like most students score somewhere between 70 and 90. Okay, so between C and low A. Now, by the way, this data is completely just made up. I just drew this picture. I don't know. I haven't collected this type of data, but anyway, I could have, right? So I could have done this for my previous classes, Now, the order here matters, okay? And there are also no gaps, okay? You will not see gaps in between the bars, okay? So that's your frequency histogram and relative frequency. Again, the same thing happens here. We have the same shape. Order matters, no gaps. That's the difference between histogram and a bar graph. Okay? Alright, so again, what's going to happen? I'm going to give you a bar graph and I'm going to tell you what it represents. So you will have some labeling on the x-axis and on the y-axis, right? So this will either represent count or proportion, and then this will represent the data itself. So over here I have scores, right? So scores that fall between 40 and 100%, okay? And then I'll ask you to answer a couple of questions. So what would be a good problem to review? Problem 4 over here. So if you take a look at it, so we have number of cars sold for a week, right? So per week. So looks like there was no time when 9 cars were sold, and there was 1 week when 10 cars were sold. So to answer questions like that, you just look at the graph carefully, you read the question carefully, you retrieve the information, you answer it. Okay, that's all there is to it. So let's go back here and see what else we have. Shapes of histograms. Okay, so now if you have your histogram, you can put a curve that sort of covers most of the information, right? So let's say what we have here, and then what type of shapes we have. So let's talk about these 3 types of shapes. This one right here, we call this symmetric, right? Another word for it is bell-shaped. And this represents a Gaussian distribution, or in other words, normal. Okay, we can also say it's approximately symmetric, and there's many normal distributions out there, as you guys already read in chapter 6. Then the 2 common distributions that sometimes students have issues with are skewed. So for example, let's take a look at these and make sure that we answer these correctly. Okay, these are skewed distribution. Now this one, a lot of you might be tempted to say that this is right skewed. Yes, so most of the data is sitting on the right. That's true, but the tail is on the left. So wherever the tail is, that's what we say. We say this is left skewed. Okay, over here, this would be most of the data is sitting on the left, right? You have a longer tail on the right, so this is right skewed. Okay, and depending on the situation, one of them would be better than the other, right? So let's say if I wanted to collect information about test scores, then left skewed distribution is good. That tells me that, oh, most of the students did really well, right? So most of the students did very well. The scores are high, so that's what the main concentration is. And just a couple did not so great, and that's why we have this tail over here. Okay, now what if we have test scores and a graph that looks like this? Well, that's bad. That tells me that, wait a minute, most of the students did really bad and there's only a couple that did really well, right? So, but in reality, this rarely happens with me. So I would expect to see something like this from you guys. Okay, no pressure. So symmetric or bell-shaped, left skewed, right skewed. Okay, what else? Let's see, what else can we talk about? Unimodal and bimodal, right? Uni stands for 1, bi stands for 2. Unimodal, you have one peak, right? So you have one observation that happens more often than any. So if you take a look at this activity here, Okay, this one is unimodal, and this bar right here is the tallest. So whatever this observation is, the frequency is the highest, right? So that's a unimodal distribution. So what would it look like? Probably something like this. It could be skewed, right? So, but over here you have one bar that's taller than any other ones. Okay, and then bi, that's 2, so you can have a distribution that looks something like this. Okay, so now, but take a look at it. These don't necessarily have to be exactly the same, as long as you can see that they're clearly well-defined 2 peaks, right? So there's 1, 2, and they're kind of separated by this dip right here. Then you say this is a bimodal. This is unimodal, bimodal. Okay, again, I'm going to give you a picture and let you choose whichever one it is. So it's either left skewed, right skewed, or bell-shaped, or it's unimodal or bimodal. Okay, that's it. That's your entire section. Chapter 2, 2 sections, just reading information carefully and answering the questions. All right, thank you for watching. On next to the next chapter.